In this video, we are going to find a limit. It is limit x approaches 0, tangent x minus sine of x divided by x cube. To solve this problem, we are going to simplify this argument of limit by using trig properties or trigonometric properties, and then we are going to take the limit. We are going to have to use the properties of limit as well, some of the properties of limit. So let's go ahead and simplify this first. Tangent of x, as you know, is sine of x over cosine of x minus sine of x, all of it divided by x cube. Now what I am going to do, I am going to multiply this by cosine of x and divide it by cosine of x so that we have the common denominator. I have cosine of x here in the denominator, I have cosine of x in the denominator here, and that's going to give me x cube on the in the denominator, but on the top in the numerator I am going to have sine of x minus sine of x times cosine of x, all of it divided by cosine of x. Now I could factor out sine of x from here. There is a sine of x here, there is a sine of x here. If I factor it out, I have sine of x times 1 minus cosine of x, then times 1 over cosine of x. So I write this cosine of x as a product on the side, 1 over cosine of x, and in the denominator I have x cube. Now I am going to simplify this further. If I simplify this, I get this. So this basically. Now the thing that you need to know in going from here to there is that basically 1 minus cosine of x, I simplify it by using this formula. Remember, cosine of 2 theta is equal to cosine square of theta minus sine square of theta, right? I could write it as cosine of 2 theta is equal to cosine square of theta is 1 minus sine square of theta. So just this one, then minus sine square of theta, right? If I simplify it further, it's going to be cosine of 2 theta is equal to 1 minus 2 sine square of theta, right? Now I'm going to move the sine square theta to the left, 2 sine square theta, 2 sine square of theta, and I'm going to move this guy to the right. So move this to the left and that to the right. So that's going to give me 1 minus cosine of 2 theta. So in our case, I'm going to put it right next to it so that you can see and compare. So cosine of x, right? So here I'm going to have 2 sine square x over 2. You have 2 theta here, you have theta here. You have x here, you have x over 2 here. So that's how we got this guy. Okay. Now things become pretty straightforward. So let me simplify this a little further, and after simplification, this is what we get. Now let me explain how I go from here to here. So I have x cube in the denominator, so I'm gonna write the first sine x as sine x over x. Then I have sine square of x over 2, so I'm writing it as sine square of x over 2 divided by x over 2 square, whole square. Then times 1 over cosine of x. Now if you do the math here, kind of note that we had a 2 here in the numerator, but I have 1/2 here. How did I get there? So I had 2 there times, if you look at this, if you flip it, what you're going to get is going to be 4, because 2 square is going to be 4, and in the bottom you're going to have x square. Then this x square and x is going to give you x cube as you needed to have. So now, what do I need to multiply 4 by in order to get 2? So it's going to be 1/2. Okay, so that's what it is. So because all I have had was a 2 here. Let me try to go over this again, because this is the sort of crux of the problem. You need to know how to organize these terms so that you can take the limit. And also look, I have structured it in such a way so that I have a situation where I have sine theta over theta, and you know that limit theta approaches 0, sine theta over theta is nothing but 1, right? So once again, how we go from here to here, sine x is sine x, so sine x divided by x, so there are x cubed there, 3x's multiplied, then I have x square left. So this sine square x over 2, sine square x over 2, I divided by x over 2 whole square. So that gives me a square term for x here and x from there multiplied together, that gives me x cube. Now in the denominator here, technically you have 1/2 square, right? Where do I get it from? X over 2 is the same as x times 1/2, right? So if I square this, I'm gonna square this, right? This is gonna give me x squared times 1/4, right? So 1/4 in the denominator, if you express it as a product, is gonna be 4, right? So but I have a 2 here, so I need to multiply it by 1/2 so that I have 2. So that's exactly where this 1/2 comes from, and 1 over cosine x is just 1 over cosine x right here. Now I'm gonna do slightly more simplification so that things are clear to you. So let me go ahead and do that simplification. So that simplification is pretty straightforward. I just broke this down into 2. Okay, sine x over 2 over x over 2 times sine x over 2 over x over 2, this. So I have taken the middle term and I have written it as a product. Now this final expression I have gotten is very straightforward, and we can take the limit of it. By the way, limit of the given thing, which is this, is the same as the limit of this. So now I'm going to take the limit. So look, this is what I get. Limit of tangent, limit x approaches 0, tangent x minus sine x over x cube is gonna be equal to limit x approaches 0 of this whole thing inside the square bracket. Now remember the product rule for limits. So limit x approaches a, f of x, g of x is the same as limit x approaches a, f of x times limit x approaches a, g of x. We are going to use this property repeatedly, of course, right, to simplify this one. And of course this is a constant, it doesn't depend on x, we can bring it outside. So now I'm going to break it down into pieces. If I break it down into pieces, this is what I get. Okay, so this is what I get. So I apply the limit here. So limit here to each of the terms inside this square bracket. There is a slight typo here. This should have been x, sine x over x. And if I do that, I get the following. 1/2 is a constant, so it can come outside. Then the limit of the first term, which is this, limit of the second term, which is this, a limit of the third, which is this, limit of the fourth, which is this. So this, this, and this. So consecutively to each of the factors I apply the limit, or each of the products I apply the limit. Then it breaks down. So this line continues to here. So now I'm gonna just simplify it further. So what I'm gonna get is this. Let me just write it out. So there is a little bit more simplification here, but not much. So it's the same as the last line here, what I have had. Only difference is that right here and here, I have changed this x to x over 2, right here and here. By the way, if x approaches 0, then obviously x over 2 also approaches 0, right? So that's what it is. Why did I do that? Because instead of x as an argument of sine, I have x over 2, and in the denominator I have x over 2. The same here, same here. This is just a clarification. Now things become pretty straightforward. Limit x approaches 0, tangent of x minus sine of x divided by x cube, right, is going to be 1/2 times limit x approaches 0, sine x over x, you know it's 1. Limit x over 2 approaches 0, sine x over 2 over x over 2 is 1. Similarly, the next one 1. And the last one, limit x approaches 0. As x approaches 0, remember cosine of x goes to 1, right? So this is also going to be 1. So the whole limit becomes just 1. So then we have the final answer, which is limit x approaches 0, tangent x minus sine of x divided by x cube is equal to 1/2, and that's your final answer. So that means the limit of this expression is 1/2. Now let me summarize what I have done here. Basically what I have done is taken the given expression, tangent x minus sine x over x cube, and then simplified it using the trig properties, and then I have restructured it in such a way so that I can apply the formula limit x approaches 0 sine x over x is 1. Okay, so that's the main formula that we have used here, and then after using that we just simplify it and we finally get this answer. I hope that this discussion was helpful. Thank you very much.